Okay, good morning. This is
GreatMath number 122.
GreatMath122. So yesterday we built these two shapes out of Zone. Do you remember what those were?
They were 16 cells.
Okay, and what does that mean?
They have 16 of a certain shape in them.
Okay, can you tell what shape that is that they have 16 of?
But they think they have 16 tetrahedrons.
Okay.
Like here's one, but they're not regular tetrahedrons.
No, they're not.
They're in the fourth dimension there.
They're in the fourth dimension. So it turned out there, I think, are 4 ways to make this shape out of Zone.
Yep.
But I found a 3D printed version.
Yep.
That looks like this. Can you hold that for me? And maybe you can hold it from one of the corners. Maybe I can zoom in on it with the camera. Alright, so can you rotate that around just a little bit, keeping your hand roughly in the same spot so it stays in the camera? Yeah, that's great. It's a pretty cool shape.
Yeah.
So here's what I wanted you to talk about today, if you can. How can you see that this shape is the same as this shape? There are different projections from 4 dimensions to 3 dimensions. Actually, which one do you want to compare it to? This one or this one? We'll just pick one.
This one.
That one? Okay.
So both of them have 16 tetrahedrons.
Okay. Can you see one of the tetrahedrons in this shape?
So there's one of them. Not really. So there's one, these yellow struts coming up like this.
Alright, and what's the base of that tetrahedron?
The base is this blue triangle.
Okay, interesting. So we got a blue triangle with yellow struts coming up, and that makes a tetrahedron.
We have another blue triangle, but this time with red struts coming up.
Oh, interesting. So that top ball seems to be part of 2 different tetrahedrons.
Mm-hmm.
Okay. And what can you tell me about some tetrahedrons in our 3D printed shape?
So there's one in the center.
Maybe if we hold it like this.
There's one in the center.
Interesting.
And then there's there's some of them. There's one here. Another one here. There. And then that makes 4 tetrahedrons, and if we go up here, then there's 5, 6, 7 more.
Uh-huh.
And then there's these elongated ones, 8, 9, 10.
Uh-huh.
Then there's the ones on the faces, 11, 12, 13, 14. There's the one in the middle, and then the 16.
Oh, wow, you counted all 16 of them. Awesome. Wow, great job. Now, you noticed on this one that top ball was part of 2 tetrahedrons.
Yep.
Can you see if the top point on this is part of 2 tetrahedrons?
It's part of this one here, and then the big one.
Okay, is it part of any other tetrahedrons?
It's part of this on the face.
Uh-huh.
And then there's the one right here, so it's part of 4.
Okay, how many face tetrahedrons is it part of?
It's part of 1, 2, 3.
3, yeah. So how many tetrahedrons so far have you found that one's part of? Whoops.
We found these face tetrahedrons. We found it's 3. Then this one in the middle, kind of 4. And there's the edge 5, 6, 7 tetrahedrons.
Interesting. I'm not sure how many each ball is part of, but that's pretty cool.
Yeah.
It's hard for me to see that these are the same shape. What do you think? Do you think they're the same shape? Kind of weird how 4 dimensions
They're
works.
they're variations of the shape.
Yeah. It's pretty neat how different shapes have different variations, isn't it? Should we look, see if we can find a video online about the 5 cell?
Okay.
Alright, let's do that.